Okay, great. Just to check, is that microphone moving? Oh, brilliant. That means that I'm being recorded. Past experience of getting that wrong. So welcome to the R255. Who amongst you is, I've got the list somewhere, but is actually submitting written work for this? Eric, Rajim, I think there should be more than that. Anyway, yeah, well, you know, whatever. What I'm going to do, we'll not go through that too much today. I was thinking about how to do that. And what I'll do is, after this session, I'll email you a list. What I want you to do, if you are submitting work for this, I want you to email me telling me which of the sessions you'd like to do, 1, 2, 3, right? But the trick is going to be that the people who do the first sessions, the soonest ones, are going to get the first choice of papers. Okay? So we're going to have a number of papers. So if you do it earlier, like sooner, you get to choose first on the paper. I don't know if that's fair or not. Interesting. We're going to talk about fairness in today, and we'll explore whether that's fair or not. Because maybe actually is, you know, I think it is better to do it earlier because work will build up across the term, right? Anyway, so bias, variance, and fairness, stochasticity, and decision-making. So this is something that I've been very interested in for some time. And I thought it was a great opportunity to sort of share my thoughts with you. And actually, the shorts go all the way back to this book that I have to be careful because this video is going to be public. A friend of mine who's when we were talking a number of years ago, and he's a barrister in digital law, and I was trying to raise some of the challenges around machine learning. He said, "Oh, you should read this book. It really covers decision making from a justice perspective." And Michael Sandel's I don't know, he's at Harvard. I don't know, he's a professor of. I thought it was awful. Really didn't like it. It was so simplistic, but it was very good for me in a lot of ways, because then I had to think about why I didn't like it, and I'm going to try and share. And he's a very good speaker, I should say, and he's very popular. He's got these lectures at Harvard where thousands of people attend and scream. You know, it's like the Beatles. And so he's clearly got a lot going on, but I'm a bit of a contrarian, so maybe that was what I reacted against. But I'll tell you what I converted into as a rational argument rather than an emotional reaction that I disliked. So what I kind of really disliked is that the way he treated the trolley problem. And it's a long time since I read it. So, and I did write a blog post about this at the time that I'll share with you my sort of fresher thoughts. I was rereading it recently. But who's here is familiar with the trolley problem? Yeah. By the way, whatever I'm going to say about the trolley problem now does not apply to the original papers which use it. Do people know what it was used in the first place? It's actually used in the 1970s in the context of Roe versus Wade in arguments around abortion. And it's used beautifully as a wonderful sort of tool to sort of bring out these things. And I think that the first author is, she's called Philippa Foot. And because I really went back to the source so I could really kill this problem. And it's like, oh no, that's really well done. It's since then, but it's been used in this very simplistic. And what I feel is both an unappealing way, but very revealing about many of the problems we have with machine learning. So your initial sort of thought is, oh, this is ridiculous and oversimplistic, and it's just a bunch of simplistic philosophy. Oh, and it's exactly how we're doing machine learning in practice is the sort of the message of this thing. And you're going to explore how and why that's happening. So the trolley problem is this idea that you have a choice, you have the control of a switch, and there's this trolley, and it's an American problem. So a trolley means a streetcar, not like a shopping trolley where it would be less disastrous. A streetcar from San Francisco is hurtling down a hill. It doesn't say all this in the paper from memory, but this is my assumption of it. And it's going to kill these 5 people who've been tied to the track. You have the option to switch the points on the streetcar. By the way, as an engineer, that is not going to work. The trolley is going to fall off there and potentially kill all 6. But these are philosophers. So as soon as I see that, I'm thinking, yeah, problematic points here. We'll get onto that. But you don't get this picture necessarily. So you think you can save 5 lives and kill 1. And then people say, oh, wow. And most people would choose to do this, right? They would choose to switch the points. And this is often, so one of the things Sandel looks at is utility theory as a way of sort of justifying this. So the utility theory is quite kind of interesting. Well, I shouldn't say utility theory because I think we have to be a bit careful. I'm not an expert in philosophy and I'm not an expert in utility theory. But I've read around them a little bit. So what he talks about is utilitarianism as a philosophical way of dealing with this, right? And utilitarianism goes back to, I think it's sort of the 18th century, a guy called Jeremy Bentham, who you can see. Does anyone know where you can see him? At UCL. His mummified body was in display on the Students' Union for a number of years. And it's been moved because the students kept on doing things to it. And a guy called John Stuart Mills, who was a sort of protege of Bentham, who was like the son of a friend. And it was all about the notion of what decision should you make? You should take the decision that maximizes happiness, right? And then all these complexities arise from it in philosophy. For example, John Stuart Mills has this notion of different types of happiness, which becomes sort of a bit problematic in utility theory. So it's like the happiness you gain by a night going out on the town in Cambridge and, you know, drinking a lot and, you know, have a great time. You're getting a lot of happiness there. The next morning you've got a bit of a hangover versus a night of sort of reflection and reading literature or absorbing music, different types of happiness, he says these are, which becomes problematic if you want a utility theory where you're just trying to sum these things up and sort of say the right action is the one that maximizes this one number. And that just really maps to utility theory and machine learning. So in machine learning, you see most machine learning algorithms, if not all, have some notion of objective function, a cost function, a loss function, an error function, whatever we want to call it. We're either minimizing loss, and if we just change the sign, that's equivalent to maximizing utility, or we're maximizing some kind of objective. So the really interesting notion underpinning this is that you assume that the result of a decision can be evaluated mathematically and can be quantified, and therefore you can make decisions on that basis. It's a cornerstone of everything we're doing in machine learning, right? So one of the things this really leads to, very powerful, is the approach to sensitivity versus specificity. So for example, one example you may have come across, is in medical diagnostics. So if I have a simple diagnostic test that attempts to decide whether you have some form of cancer, so it might not, maybe a breast mammogram for breast cancer, or, you know, cervical smear test. These tests have what's called, you know, they've got a false positive and a true positive rate and these sort of things. And there's an interesting, you have to sort of look at these things. And the problem is if you sort of say everyone who's got any possibility of having cervical cancer should go to the doctor, the health economics doesn't work. The cost of dealing with that is enormous. So you end up having to make these trade-offs on terms of how many false positives versus true negatives you're prepared to accept within your ecosystem, because there are costs associated with the follow-up tests. And no one likes to put money on lives, but fundamentally, if you don't try and evaluate these things, you also don't have infinite resource. So this is a sort of resource matching problem. So you end up balancing the sensitivity versus the specificity of the test by trying to put these costs on. And it can be a problematic thing. And the sort of modern domain would be known as decision theory. I think the really interesting thing that I found out by reading this is the philosophical literature talks an enormous amount about what Stuart Mills and Bentham said. I think they're very, very interesting people. A lot of what they say is very interesting. It's interesting to read about. But, you know, they exist in a world that is before a deep understanding of calculus, right? And probability in some sense. So you really have to take it with a pinch of salt. You know, so for example, my notion about why Stuart Mills thinks there's different types of happiness, I would say, and we'll come on to this in a bit, is I think if, you know, I suspect there's evidence to back this up, which is my personal feeling, is that we're not sensitive to absolute position, we're sensitive to gradient. So happiness is about making progress, right? And the night of debauchery feels like a lot of progress in the moment, but the next day you're back to square one. So it doesn't integrate, right? So over time, if you integrate debauchery, you just are getting nowhere because it's just occasional peaks. Whereas these other forms of happiness, getting into something, developing your understanding of machine learning, it integrates over time. You're constantly building something out. So that's why I think they feel different, because you're actually sensitive to gradients rather than, and that gradient is something that can persist for literature. It doesn't really persist for the night of debauchery. I mean, you can do it every night, right? But you're not building on the night of debauchery. If anything, you're losing the thrill, right? Would be my theory. We can try an item debauchery if you like. That's just my thoughts. So the basics are you have to define this utility function. But I think the really thing, so I like this, I like this sort of poem, Tiger, Tiger, Burning Bright. And I think that if you look at, what's the name of, it's terrible. He also painted Newton, and I use him all the time. It's the name of the poet. He's from the same era. And wrote Jerusalem. I mean, he's a really interesting artist. It's terrible, I've forgotten his name. Someone look up who wrote Jerusalem, and we'll come. William Blake, thank you. So, poem by William Blake, right? And William Blake actually exists in a similar era, and he's reacting to the way that science is reducing the world to simplistic things. And he has a lot of really interesting works. His painting of Newton, if you go to the British Library, there's a statue of it. And the British Library is like celebrating Newton. Blake is cursing Newton for this reductionist perspective that is undermining the complexity of the world. And I think that complexity is emergent because of uncertainty. And if you've done L48, you'll know that one of my feelings is that the computation is at the heart of that. The lack of computation is one of the reasons why we have that uncertainty. But that uncertainty manifests in very interesting ways. So when you look at natural systems, and Blake was very interested in sort of natural systems versus artificial systems, you find really interesting comparisons. So artificial systems are designed, whereas natural systems are evolved. And I think that goes to the heart of the challenge here. And they're evolved in an uncertain and shifting environment. So one of the things that I think it's a misrepresentation of the original work. I mean, and there's lots of interesting issues about whether we want to think about evolution as something we're sustaining. So difficult subject here. But even this term around evolution, survival of the fittest, is such a misnomer. Evolution is not about survival of the fittest. It is not. It's about non-survival of the non-fit. Now, what does that mean? That sounds equally cruel in some senses, but it doesn't have a notion of what is best. It has a notion of, that didn't work, right? So if there was single objective function, and okay, if that was with a single maxima, right? What you would find is that evolution would lead to one type of species, but actually evolution is just about persistence. So there's trees outside, we say, what is better, a tree or a human being? Doesn't matter, they both persist. Evolution doesn't have an opinion on that, right? So this term, that there's some sort of fitness underpinning evolution, is simply, to my mind, wrong. Right? It's broken. And it actually led to a really problematic thinking like eugenics, right? If there's a sort of form of fitness, we should look to optimize it. So let's work out what we think it is, and let's have those people mate, I mean, okay, that's actually how we bring about artificial breeds and stuff like that. But what we create is very non-robust species, right? So the sort of things that our cows and our wheat and all these things are very fragile in practice. They have to be sustained and curated by humans. They produce larger yield. So best for us, but not actually capable of surviving any longer in the wild. So that's where you're sort of seeing the worlds of design and evolution converging. So if you look at a natural intelligence, that's kind of what they've emerged in. It's like, well, they haven't messed up yet. I mean, and they will all mess up at some point because everything seems to die out eventually, right? Including us, but they just haven't messed up yet. So that's coming from Herbert Spencer, who was very involved, I think, in this movement of social Darwinism, which is the very problematic movement that follows Darwin, which is about, we can engineer society to sort of do things in a good way. Jonathan.
Didn't Darwin publish his On the Origin of Species only like in the 1870s?
So this is a couple of years after, yeah. There we go. Thank you. Look at this. It's useful having people in the audience. So I kind of think, and actually I thought about this and wrote it. I think it's probably also a problematic statement. We have to be a bit careful with it. But interestingly, I found someone else had written it, and I haven't updated this slide since then. So this has been said by other people as well. So the mistake we make is we equate fitness and objective function and assume a static environment and a known objective when we're sort of thinking that we can then design things and put them in these environments. And you just can't, right? Because what you tend to see is whenever we design something artificial and deploy it, the way that it's assimilated in the environment is we control the environment around it. We put machines in factories, we put trains on railways, we sort of force people to turn up at the station at a certain time. We say, don't cycle on the motorway. You know, the notion of driverless cars to me is a nonsense unless you start introducing quite draconian rules about who can do what on the roads, right? Because if I can walk on the road, then I can just always walk in front of a driverless car. And, you know, well, I won't walk in front of a car with a human driving it because I suspect they might kill me. But if the driverless car is guaranteed to not kill me, I'll just walk in front of it. You know, this the world of uncertainty and is actually what allows that complex interaction to work, because I won't walk in front of a car if you're driving it, right? But once I know the car's guaranteed not to kill me, I'm just going to stop it moving by taking priority. So what it sort of leads to me, I had this thought once, there's only one absolute policy we should follow. There will be no single absolute policy that should be followed in save all slavish circumstances, because there is no notion of truth, right? Oh yeah, there will be no single, sorry, yeah. Will be a single, yeah. Yes, there would be no, thank you. That's kind of important. So, you know, the response to this is basically, you don't, all bets are off, sort of at all times. And actually, this is known, like if you go back to Pyrrho and the Greek skeptics sort of talked about this. You can't trust anything. You have to, dealing with that in decisions is quite hard. But the solution is sort of from, in this paper by George Box. So George Box is famous for sort of saying some models, all models are wrong, but some are useful. And that's a great quote, but I've kind of gone off it because people introduce that at the beginning of their talk. Then they explain their model is wrong. And then they say, therefore, it might be useful. And that's not the way the quote's intended. And this is the sort of more important, relevant thing that they should be talking about. Since all models are wrong, the scientists must be alert to what is importantly wrong. It is inappropriate to be concerned about mice when there are tigers abroad. So you can see now I'm going back to the tiger of uncertainty, William Blake, right? Tiger burning bright in the forest of the night. You know, there's something out there. It's going to eat you. So what happens when we bring the tiger to the trolleys? So sorry, that's the wrong way around. So this is the second example of the trolley problem. And this is the one where it gets really ridiculous. Because the notion here is, and the language is, even in the original paper, is not modern politically correct language. So here the notion is that you no longer have access to the switch, but you observe a fat man. And the fact that the man's fat is important in the reasoning because they're heavier than you. And the reason that they're heavier than you is that they are sufficiently heavy to disrupt the trolley if you put them off the bridge, and you are not. So you're trying to eliminate, you can see what they're trying to do. They're trying to eliminate the answer, I jump in front of the trolley and save everyone, right? They're trying to eliminate that. So that's why the man is a fat man. It's terrible, isn't it? And the notion is that instead of switching this switch, you're going to push this man off the bridge and the trolley will be deflected, right? And then surprise, oh, Michael Sanders like, oh, and shockingly, people don't do this. You know, oh my God. I think there's this, this is an example of overly focusing on models and thinking that models are helpful and not understanding the limitations of the model. And the model here is a spoken model. And the notion is that the philosopher is telling you these things are going to happen. And they're ignoring the fact that a picture like this is appearing in your mind. And whenever the picture appears in my mind, I always think of, there's a viaduct in Sheffield, which has a quite large stone wall on the side. And I'm picturing my fat man standing there. So I've got to heft this fat man over the parapet, right? And he's already heavier than me, right? And also I know that this is a delicately balanced situation because somehow I know I've been given that, even though how could I ever be given that he's sufficiently heavy to stop the trolley? I'm not sufficiently heavy to stop the trolley. I mean, what kind of bullshit is this? I mean, it's like, so he's heavier than me. So any fight with him is not going to end well for me if I'm not catching him by surprise. So I'm really going to sneak up behind him as this situation is unfolding. And I'm also going to have to land him really squarely on the tracks because if his weight is slightly off the track, I know he won't disrupt. It's just ridiculous, isn't it? I mean, compare that, your natural sense of uncertainty in the two situations is so different. One is like a mechanical switch. If it doesn't work, it doesn't work. The guy who survives is kind of pissed off with you because he saw you switch it. And he's like, what the fuck, mate? But in this situation, I actually, because I'm so obsessed with this problem, when I used to be working at Amazon, I used to go running around South Lake Union in the Pacific Northwest. And there's one point where you loop the lake, right, where there's actually not even one of these parapets. There's just a one of those floating pontoons, so that the road goes over a bridge and you can go down on this pontoon. So there's not even like an edge on the pontoon, it's right by the water. And I was running up to it, and there was a guy who was larger than me fishing on the edge of the pontoon. And I'm just immediately thinking, could I push it? I didn't. But, to be honest, I'm looking at that thinking, I'm not sure I could. And certainly, I think I could probably, I probably could, right? But the fear of the sort of the thing, and could I push them in accurately? No way. And there was no parapet there. It's just ridiculous, isn't it? It's absolutely ridiculous. And no one actually points this out. I actually wrote a blog post that points this out. And then I heard someone on Radio 4 once, I think using my blog post to make humor, which was a bit odd. And I thought, that's weird. Anyway, maybe they just thought the same thing independently, but it's certainly not in Sandal's book, right? So uncertainty is really, really, for me, the key here, right? These situations are massively different because you have an extraordinary instinct about levels of uncertainty and what they mean. And the challenge, though, is that sort of behind all this, that's often not embedded in our machine learning algorithms. And that's what I want us to think about across this project, because whatever we can be critical of people in the past, we can be critical of these early statisticians who all got involved in eugenics and the simplicity of what they were doing. Implicitly, we're doing the same thing, because we're not doing it consciously. We're not saying, oh, let me evaluate these things in practice. We're just making a design decision to use a particular objective function to deploy a model, and then we're shipping it, and it's being shipped at such a scale that it's being imposed on society. So we are making value judgments without even making the value judgments, which maybe it's slightly better I would argue, but it's still highly problematic. It's not direct people making dodgy value judgments, but it's implicit. And just as problematic in the end, even if the motivation is better. So you may have heard of sort of Daniel Kahneman, and everyone goes on about the fact that he's Thinking Fast and Slow is his book, but really that's not his contribution for his Nobel Memorial Prize. His Nobel Memorial Prize is based on the back of prospect theory. And prospect theory is sort of towards the back of the book, all the funky bits in the book everyone remembers of this notion of thinking, of reactive thinking and reflective thinking. But that appears in many different literatures. But what Kahneman really cares about is when you're doing your reactive thinking, what is your cost function? So I still have a scar on my shin from when I knocked my laptop off my standing desk and made an instantaneous decision to try and catch it with my foot, which was some kind of balanced decision about the utility of breaking the laptop versus having a scar on my shin, which I didn't have any time to think about. So I guess there's differences in whether we're reflective or reactive in our decision making. And Kahneman tries to describe, basically it turns out he thinks that you need an empirical approach to describe how humans will react to these sort of things, and which is a sort of modern view on these utility theories, because of course utility theories dominate in economics. So this is behavioral economics trying to say that in practice humans aren't rational. But there's lots of stuff in there that I kind of also find slightly annoying. I don't want to talk about, in practice, even Kahneman, I think, falls into this trap that there's some kind of universal rationality. Maybe he doesn't quite in the same way that we're sort of aiming towards. Whereas I always argue that actually in practice, whatever your individual utility is, if it does exist under Kahneman's prospect theory, it's going to be highly subjective and personal, and it should be. And the reason is because if you are going to have any utility, and I'm not sure that we do, but if you were to have a utility, then it would be in the species' interest for everyone's utility to be slightly different, so that we all reacted to the same circumstances slightly differently, so we don't get all squashed by the same catastrophic events, right? We don't all, having some people make the wrong decision, what looks like the wrong decision in a world of uncertainty is a good thing, because it looked like the wrong decision, but probabilities fell the other way and it turned out to be a better decision. So you kind of want to spread your bets across your species, and that's sort of the thing we do. So I kind of feel that when we look at our own decision making, I think and Kahneman talks about this and says it's a bad thing. And I think exactly the other way around. We have a cognitive bias towards variance. So two experts, given the same facts, will come up with different conclusions. And I think that's an extremely good thing. So this relates to something, and this will probably be one of the papers I set, called the bias variance dilemma. So whenever we look at, even under these utilities, so even if we accept the utility, right, that we can look at a utility in different particular circumstances, and the utility used in this paper is squared loss, you can decompose your errors into two parts. One is known as the bias, and the other is known as the variance. And this is a sort of machine learning approach, right? The bias is you make errors because you've oversimplified the situation. You didn't take into account the nuance. The variance, sometimes it's referred to as overcomplexity, but it's rarely that your model is too complex relative to the world, because the world is very, very complex. It's that your model is too complex to fit all the parameters given the data you have available. So your actual errors tend to decompose into these two parts. And what I think we have is, if we think it in those technical terms, is a cognitive bias towards variance. And the reason we have this cognitive bias towards variance is it's kind of important that the type of errors we're making are inconsistent. So if you can access truth, consistency is good. If you know you're going to make errors, making those errors consistently is very, very bad. Yeah. And one of the problems I see in machine learning is that's what's happening, because we tend to err with our machine learning models towards biased models, towards ones that oversimplify because they generalize well. And so what I'm interested in for this course is looking at where stochasticity could come in and help, and selecting some papers that give a sense of that. So your sort of final project will be to sort of give a sense of how you think all this fits together given the current literature. You had a quick one.
Yeah, so I think I get a general sense of the kind of models and things that you're talking about, but could you please give like a concrete example of how it erred over area towards the bias and the variance side with practical models that we're following?
Yeah, so here's SVM fitted to some random data, right? And if you look on the right, that's a model that's exhibiting variance in its error. And if you look on the left, it's a model that's exhibiting bias. Okay, so if you look on the right, you'll see occasionally it does really interesting things, like it says that error up there is green. If you look on the left, that's never happening. Yeah, so imagine that you're a discriminated against category. So you're one of these entities here, or I mean, you're not, well, whether you're discriminated against or not, you are, under the consistent error, by you being slightly unusual in this model, you are consistently made errors about, and consistently made errors here. Whereas the errors on this side are inconsistent. So if we sort of took you, if you were a population, if we sort of say, Cambridge ACS master students and part 3 students are discriminated against, and we put you in front of a judge, if a judge made errors about you, every single one of you going in front of the judge, you would all get the same error under this model, because you'd be fitting in this sort of category here. Whereas in this case, the nature of the errors change, right? Because there isn't enough information to fit the decision boundary, so the decision boundary changes radically. And the case on the right is much closer to how humans behave. The case on the left is close to how the models we deploy and practice behave. So my theory is that you create new categories of discrimination under this model, right? That didn't exist before, because the way you're making errors is consistent. Right? So and you don't even know those categories of discrimination until you've done it for some period of time. So that maps into, I'll just leave all that because it's short out of time. That maps into things like the GDPR, right? So what the GDPR tells us is there's certain categories which you shouldn't discriminate: race, religion, medical condition, sexuality, gender, right? It tells us these are categories you're not allowed to discriminate on the basis of that, which, the interpretation of that is quite interesting, but the interpretation of that in machine learning is very particular in terms of the way people tend to think about fairness in machine learning is what I would call substantive fairness. So what they're sort of, or outcome fairness sometimes referred to. So they then try and look at the machine learning decision, and they say, oh, can we show that this system isn't discriminating against those groups? So like, there's various measures we can use for that. And I've got to research the paper by Maurice Hartz that talks about these different measures, where they do things like, well, so for example, in the loan or in the submission to come to this university, demonstrate that your outcomes are equal across groups. There's not one group that's suffering under whatever your selection criteria is. So that's outcome fairness. But that's not the only notion of fair. So I love thinking about kids, and this is interesting. We'll have a paper on this that Jonathan's also already read, and I think Sarah's also read, which is about what it means, well, whether it is, what it means to be fair. Actually, the paper is slightly different. So fair is a sort of English word, but what it actually means to be fair can sometimes be used, well, that was unfair because the rules of the game changed. So like if I were to set this course, and I would say in the way, and I'll give everyone an A+ if you get over 76%. And then like later on, I said, oh, I changed that. You had to get over 90%. You would say that's not fair. Right? And the reason that's not fair is actually different. It's outcome fairness. It's a procedural fairness thing. So that's sometimes called procedural fairness, or I think of it as a performative fairness. Now, this thing is quite nuanced because you really have to be quite careful to take into, if you're not just doing that across categories of discrimination, but you're trying to take into account someone's background. So someone who's not in a protected category comes to you and sort of is interested in applying to do a PhD or master's or whatever else here, and then you hear their background and the sort of things they've got through in order to get to the position where they're in, really, they're ready to go. And taking that into account requires an enormous amount of nuance and understanding, right? And it can also be gamed. They could misrepresent themselves, right? Whereas if we just have a rule that says, these are the marks you need, and then you get in, right? That has to be really simple. So these two things are actually in tension, right? So the sort of like having a simple set of rules to get into the university versus taking into account the difficulties everyone's been through to get to the point are in tension. And in practice, we resolve that tension, I believe. I call it the marvelous resolution. There's one thing that can be incredibly nuanced, but people think of as very simple. What is that thing? Other people. So, in fact, the way you interpret most complex things is you anthropomorphize them because you have an intuitive sense of people. Right? So whether it's true or not that other people are simple, you have a sense that other people are simple. But in fact, they can be, if correctly convened, incredibly nuanced and subtle. So how do we resolve this in practice? Humans in the decision-making loop. Right? That's my sort of constructive proof for why humans in significant consequential decisions are so important in the decision-making loop. But many of the problems that we're dealing now, so if you look at the GDPR, it's all about consequential decision-making. Will you get a loan? Will you get medical treatment? Will you get insurance? Will you go to university? These are consequential decisions. The challenges we're facing today in our society driven by machine learning and the problems I talked about earlier are inconsequential decisions. The fact that I get a load of ads all the time that categorize me as a certain person, or the type of search results I see. These things are not subject to GDPR. We're allowed to use machines to do them the whole time, and yet they are restricting the world around us because they have this bias. They're constant sort of errors that I don't get to see the CEO position, or I don't get to see this, right? And there's a really interesting question around how we deal with that. And the hypothesized answer I have for you, and it's something we'll explore as we go through, is that we need to sort of reject what Kahneman is saying about consistency in decision-making and look for inconsistency in decision-making, right? So that basically you have a situation, and what that would mean, is you have a situation where like one moment Facebook thinks that this is the right ad for you, but the next it thinks something else is the right ad for a person matching your description, right? So there's variation. So you're seeing the spectrum, okay? So it all makes sense? Now, we're overrun a little bit, so I haven't gone through the whole slides. I've got the notes online, and I'll share that link with you all, because I think I have all your email addresses. Raju?
I think you might, when you were talking about GDPR, you may have been using arguments that come from both the GDPR and the equality act together. I don't think the GDPR on its own specifies everything.
No, the GDPR does specify protected characteristics. Yeah, it actually specifies. Yes, you're right. There's the Equalities Act as well is covering this, but that's covering it for human decision making. The GDPR is covering it for data-driven decision making, right? So you can get around a lot of the provisions of the GDPR by putting a human in the loop. So the way I'm describing it in the GDPR is if I'm deciding to automate a decision around loans, which in practice people, it's interesting the question to the extent to which they're doing it. And that's why you end up with these things called a right to explanation. So like, which has also been studied on what that even means. Like if there's an automated decision made around me around the loan, and it's a consequential decision, I have a right to an explanation about why that decision was made. You know, provisions around that they have to demonstrate that it's not discriminating on a protected characteristic, as they're called. But yes, there is equalities legislation as well, but that would apply to sort of the way I treat as a human being employees and so on and so forth. And similar categories would come up. Yeah. Maybe we should have the GDPR as one of the papers. It is actually, you know, it's quite an interesting thing to read. It's funny because one of the things that you know, people talk about all the time, like health and safety. And then I sort of realized that I was talking about it a lot and haven't actually read it. So and it was prompted by my lawyer friend telling me something that was in it. And I thought, oh, maybe I should actually read it. And I think it's really well written. And I think that the problem with it is the terminology. I think instead of calling general data protection regulation, if that stood for good data practice rules, is the thing I often say, then you would all look at it. And if I were to give you, in fact, so yeah, maybe we should have the GDPR as one of these papers. If you were to sort of just assimilate the lessons that are in there, which would be of the form, wouldn't it be nice if the system you're building, if you could explain why it's making the decisions it's making? Or wouldn't it be nice if you knew that you built a decision-making ecosystem that wasn't making decisions on the basis of factors that have no relevance to your customers' you know, business value, right? Or whatever else like that. You know, these sort of things are kind of nice to have, aren't they? And if you read the GDPR in that way, you're like, oh yeah, these are quite good characteristics of a system. Wouldn't it be nice? The other one is like, wouldn't it be nice if you knew in your ecosystem that you could delete a customer's data, like just as a test of the quality of the data provenance in your ecosystem, you know, rather than, and not for any personal privacy reasons, that just like your quality of compute system is good enough that you know where customers' data are being stored, so they're not going to be leaked, etc., etc. And of course, the answer is people can't do this. And so it's like, so the follow-up is, well, what kind of crap systems have you built? And of course, it's because software is hard. So in some sense, I like to think of the GDPR the other way around. It should be like an input to the engineers. So yeah, we'll probably include it as one of the papers. Of course, if no one wants to select it, that's fine. Now, I think we've got quite long sessions for so what we're going to do is something Sarah and Jonathan will be familiar with because they come to a few of our group meetings, is we're not going to do PowerPoint presentations. Let me just check one thing, because I need this number before I say that. Apologies for overrunning slightly. But the reason I shortened this session is because I wanted as long as possible in the other sessions. So I was going to say, right, I was going to just say 2 pages, but then I realized, because you're all worrying about how many words you should create, I need to say a number of words. So I've just checked how many words are in 2 pages. And the answer is 400 to 500 words. So you will write up to a maximum of 800 words that summarize the paper. And summarize the paper, like I want everyone to summarize the paper in such a way that the salient points about the paper are being drawn out. And what we're going to do in our discussion sessions is we'll read your 800 words, and then we're going to discuss the paper. But we're not going to be just going, oh, I don't like what you wrote. We're going to be discussing the paper on the back of your 800 words, right? So, you know, just reflecting the fact that we perhaps won't all have time to look at all the papers. Of course, if you get through the paper yourself, that's brilliant as well, but that discussion will be led. So in effect, what I really like about that is when we were doing the PowerPoint presentations, last time I did this, it's very hard to sort of, the quality of the discussion is quite poor because people feel obliged at some point just to ask a question. Whereas the experience when we've been doing this as a sort of test in the group last term is the quality of the discussion was very, very good. And I think it's just a very good exercise as well, a better exercise than creating a PowerPoint presentation. So 800 words, up to 2 pages. And what will happen at the beginning of that meeting, well, I can't remember how many papers we've got to go through, but we're all going to quietly read your 800 words. So you have to provide your 800 words before the meeting. If anyone has sort of any issues around with dyslexia or anything like that, let me know. We'd like you to provide the paper early in the morning so those people have a bit of extra time, but it's only if you want. The idea is we read it in the meeting. So we're all fresh, we're all up to the same point. We've all seen everything that the presenter has described, and then we can have a sort of broad debate around us, amongst us, around what we think the interesting aspects are. Does that sound good? And then I think that the actual final assignment is a 4,000 word thing. I don't think I'm required to set it till the end of this, and I don't have like a specific idea, but I kind of feel we'll see where we get with some of these presentations. What I would kind of like it to be is, your opinions on answering the, do you think, is what I said right or wrong? What are the social implications, whatever else, right? And it can be, people have asked, I think already, or will it be like literature review or will it be technical things? Well, we'll have some more technical papers, some more social papers, and your choice. If you want to do get some data and show the bias variance error in practice and what happens, like that little SVM thing I did, and illustrate that technical point, fine. If that's your thing, play with a Jupyter notebook, but try and relate it back to the social question. If you're much more interested in just the social ideas and the downstream effects and relating to other things, focus on that, right? I don't have a strong opinion on that. We're trying to bridge these worlds. Make sense? So I've overrun. I should stop the I'll stop the thing, and then we'll do any, if I can work out how to stop it. We'll do any questions. Sorry, one sec. Just